Struggling with math? You're in the right place. Welcome to Explaining Mathematics, the channel where we simplify tough problems, break down complex formulas, and turn confusion into clarity. From basics to advanced topics, we explain it all step by step. Let's start solving.
All right, let's be real for a second. When you see a bunch of numbers and letters all jumbled together, it can look, well, pretty intimidating. But what if I told you it's not some secret code? It's a language, and today we're going to decode it. So you see something like this pop up. What's your first reaction? Do your eyes kind of glaze over? Does it just look like a big old math puzzle? Hey, that's totally normal. But the truth is, it's way, way simpler than it looks. So here's the secret. It's not a puzzle at all. It's a sentence. Yeah, really. Algebra is a language. And just like any language, it has its own grammar and its own vocabulary that lets us say really complex things perfectly. And guess what? In the next few minutes, we're going to give you the basics so you can speak this language too. You ready for this? Okay, let's dive in. So just like any new language, we got to start with the absolute basics, the fundamental building blocks. So let's kick things off with the most basic phrase in all of algebra. So what exactly is an algebraic expression? Well, think of it as just a mathematical phrase. It's a mix of numbers, variables, the letters like x and y, and operations like plus and minus. Now, here's the most important part. There's no equal sign. It's not a complete sentence making a statement. It's more like a fragment that just describes one value. Of course, you can't have a language without some rules, right? It would just be chaos. In English, grammar makes sure we all understand each other. In algebra, our grammar makes sure we all get the exact same answer, every single time. And that big grammar rule is something you've probably heard of before, the order of operations. Most of us remember it by the name PEMDAS. This is the non-negotiable law of our math language. So you know what it stands for. Parentheses, exponents, multiplication, division, addition, and subtraction. But, and this is a big but, here's where people get tripped up. Multiplication and division are a team. You just do them in order from left to right, whichever one comes first. Same thing for addition and subtraction. They're partners too. It's not always one before the other. Look, talking about grammar is boring. It makes way more sense when you see it in action. So let's solve this expression together. Where do we even begin? We just follow PEMDAS step by step. First, P for parentheses. 5 minus 2 is 3. Got it. Next, E for exponents. 3 squared is 9. Then we've got M for multiplication. 3 times 9 gets us 27. And finally, A for addition. 8 plus 27 equals 35. See, by following the rules, we get one single undisputed answer. That is the power of order. Okay, grammar, check. Now it's time for some vocabulary. Let's break down the anatomy of an expression and learn the key words you'll see all the time. We're going to use this expression right here to break down all the components. You can think of it like diagramming a sentence back in English class, just to see how all the parts fit together. First up, we've got terms. These are just the individual chunks that are separated by plus or minus signs. So in this example, you can see we have 3 terms, the 4x squared, the 3x, and the minus 7. Now inside those terms, you've got 2 main players. You have variables, like the x, which is just a placeholder for a number we don't know yet. And then you have constants, like that -7. A constant is just a plain old number. Its value is, well, constant. It doesn't change. And that number that's kind of attached to the variable, that's called the coefficient. It just tells you how many of that variable you have. So in 4x squared, the coefficient is 4. In 3x, it's 3. And hey, pro tip, if you ever see a variable all by itself, like just an x, it has an invisible little coefficient of 1. Okay, so we've got the grammar and the vocabulary. What's the next step in learning any language? Gaining fluency, right? Being able to say things more efficiently. In algebra, we call this simplifying. The whole secret to simplifying is this idea of like terms, and the rule is actually really simple. Terms have to have the exact same variable parts, raised to the exact same power. It's really just the apples and oranges idea. You can add 3 apples and 2 apples to get 5 apples, but you can't combine 3 apples and 2 oranges. And I mean, this rule is super specific. 3x and 7x? Yep, those are like terms. The variable part is identical. But 3x and 3y? Nope, different variables. How about x squared and x cubed? Still no good, the powers don't match. The variable part has to be a perfect clone. So simplifying is really just a game of matching. We group the like terms together. Here, we can combine the 4x and the 2x, which gives us 6x. Then we combine the numbers, 3 minus 5, which is -2. And just like that, a long, clunky expression becomes a short, clean one, 6x minus 2. Okay, we've learned to read algebra. Now for the final and maybe most important step, learning to write it. This is where we translate everyday English into the clear, precise language of math. Luckily, there are some really common keywords that are dead giveaways. If you see sum or increased by, you should be thinking addition. Difference or less than, that's subtraction. This table right here is basically your mini dictionary for translating. Let's do a quick one. 7 more than a number. Well, a number is just our unknown, so we'll call it x. More than means we're adding, so it just becomes x plus 7. See? Simple. Okay, let's try a slightly trickier one. 10 less than twice a number. You got to build this in pieces. Twice a number is easy. That's 2x. Now the phrase 10 less than is the tricky part. It means you start with the 2x and then you subtract 10. So you get 2x minus 10. The order there is so important. And there you have it. That's your complete language toolkit for algebra. You have your grammar, which is PEMDAS. You have your vocabulary, terms, variables, all that stuff. You know how to get fluent by simplifying, and you can translate. You are ready to go. Because look, algebra isn't just a class you have to pass. It's a universal language for describing the world around us, from rocket science to just figuring out your finances. What we did today was just learn the basic building blocks. So the real question is, now that you can speak the language, what problems will you solve?
If this video helped you understand the topic better, don't forget to like, subscribe, and turn on notifications so you never miss a lesson. Comment below what topic you want explained next. Thank you for watching Explaining Mathematics. See you in the next problem.